తెలంగాణ పోటీ పరీక్షల్లో ప్రభంజనం సృష్టిస్తూ స్టేట్ నెంబర్ 1 గా రాణిస్తున్న S&S పబ్లికేషన్స్.
తెలంగాణ గురుకుల 100% ఆన్లైన్ క్లాసులను స్టేట్ నెంబర్ 1 ఫ్యాకల్టీచే అందిస్తున్న కోర్సులు.
గురుకుల తెలుగు కంటెంట్ అండ్ మెథడ్స్,
గురుకుల మ్యాథమెటిక్స్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల ఇంగ్లీష్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల సోషల్ స్టడీస్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల ఫిజికల్ సైన్స్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల బయోలాజికల్ సైన్స్ కంటెంట్ అండ్ మెథడ్స్.
పేపర్ 1 జనరల్ స్టడీస్, పేపర్ 2 పెడగాజీ, పేపర్ 3 కంటెంట్ తో 100% సిలబస్ ను పూర్తి చేసి ఆన్లైన్ క్లాసులను అందిస్తున్న ఏకైక సంస్థ.
మీ ఉద్యోగ సాధనలో మీకు తోడుగా మీ S&S పబ్లికేషన్స్.
ఆన్లైన్ క్లాసుల కొరకు S పబ్లికేషన్ యాప్ ని డౌన్లోడ్ చేసుకోండి.
మరిన్ని వివరాలకు సంప్రదించండి 8070555577 and 9032064822.
Hi everyone, welcome to S&S Publications. So, my name is Nageshwar Rao. I am a chemistry lecturer. So now I am going to explain PGT previous year question paper. Yeah. So let me explain very clearly. This is very important. So please listen very carefully. So PGT previous paper. Yeah. Actually physical science contains two parts. Everybody knows. One is physics and second one is chemistry. So physics 50 questions and chemistry 50 questions. Total question paper 100 questions. Clear na? Yeah. So first physics part 1 to 50. Next to 51 to 100 chemistry question papers. Now I am going to explain completely chemistry part only. Yeah. Carry on. So this is the first question. Calculate the length of column of water that could exert 2 bar of pressure. Given height of mercury column required to exert 1 bar pressure is 750 mm and the density of mercury is 13.6 gram per centimeter cube. Yeah. So here what is the question? What we need to find? Calculate the length of the column. Length of the column is nothing but height of the column. Yeah. So here we need to find out height of the column. We need to find out height of the column. Yeah. Here we need to find out height of the column. So what was given? So here height of the column of water, we need to find height of the column of the water. Next to 2 bar of pressure. Given height of mercury column required except 1 bar pressure is 750 mm. So and density of mercury is 13.6 gram per centimeter cube. Yeah, just have a look. So calculate the length of the column of water. We need to find. Next, what is the pressure? 2 bar. Next, mercury column required to exert 1 bar pressure is 750 mm and density of mercury they have given 13.6 gram per centimeter cube. Okay. So here we need to use one formula, that is pressure formula. So pressure equal to delta GH. Yeah. So here delta is nothing but density of the liquid. What is delta? Density of the liquid. Delta is nothing but density of the liquid. Density of the liquid. Next, G is nothing but acceleration due to gravity. G is nothing but acceleration due to gravity. Acceleration due to gravity. Next, H is nothing but height of the column. H is nothing but height of the column. Height of the column. Yeah. So this is the formula. So what is the formula here? Pressure equal to delta GH. So delta stands for density of the liquid and G stands for acceleration due to gravity and H stands for height of the column. Clear na? Yeah. So here first we need to write out. We need to write column of water and column of pressure. Column of water. So here H1 we need to find. H1 we need to find. Next, what is the density here? Yeah, water density 1 gram per centimeter cube. Water density 1 gram per centimeter cube. Yeah. Next, column of mercury. Column of mercury. So H2, what is the height here? Yeah, 750 mm. 1 bar pressure is 750 mm. Next, so what is the density they have given? Yeah, 13.6 gram per centimeter cube. Yeah. So formulas: pressure P1 equal to delta 1 GH1. Let us assume this is equation 1. Next, pressure P2 equal to delta 2 GH2. This is equation 2. So just to divide equation 1 by equation 2, then you will get correct answer. So what is the equation 1? P1 equal to delta 1 GH1 by P2 equal to delta 2 GH2. Yeah. So here GG gets cancelled. Next, what is the P1? What is the P1? P1 is nothing but a pressure. What is the P1? P1 2 bar and P2 1 bar. Yeah. So P1 2 bar, P2 1 bar equal to. So what is the delta 1? Delta 1 water value. Delta 1 gram per centimeter cube. So here 1. H1 we need to find out. Next, what is the delta 2 value? So this is the delta 2 value. Density 13.6 in gram per centimeter cube. 13.6 gram per centimeter cube into what is the height here? What is the height? 750 mm. Yeah, 750 mm. So just you have to do a cross multiplication, then you will get answer. 1 into H1, H1. So H1 into 1, H1 only. That equal to 2 into 13.6 into 750 mm. You just to do a multiplication, you will get this answer, 20,400 mm. 20,400 mm. So this is the answer. So what is the answer for first question? First question means 51 question. So this is the answer. First option is the correct answer. I think my explanation is very clear. Just have a look. Actually this is a little bit different question, but not a difficult question. Clear na? Actually this question belongs to physics background, not chemistry background. Only 10% is chemistry background and 90% it is a physics background. Okay, no problem. You just use the formula, that's it. Yeah, just have a look. So first, what we need to find, that is important. For every problem there is a solution, but we need to find what is the exact problem. So when you find exact problem, then automatically you will get the link. Yeah, then you can apply it. So here we need to find height of the column. Next, what is the formula? Which formula we need to use? We need to use this formula. Pressure equal to delta GH. This is the delta, don't get confused. Yeah, delta, density D. This is also represented delta, don't get confused. Yeah. So height of the column water and column mercury. Next, you need to use this formula, you will get correct answer. Yeah. So here what is the answer? First one is the correct answer. Yeah, just have a look, take screenshot. If you want to take, you can take screenshot. This is the next question. 11.2 liter of a gas at STP. STP means standard temperature and pressure. Yeah. Weight 14 gram. Which of the following is the gas? Yeah. So here what is the question? 11.2 liter of a gas at STP weighs 14 gram. So which of the following gas? So which gas having 14 gram weight yet 11.2 liter of gas? Yeah. Let me check it. Here you need to use a simple formula. That's it. Yeah, here you need to use this formula, then you will get correct answer. Volume at STP upon 22.4 liter, volume at STP upon 22.4 liter by mass by molar mass, I think this is better, mass by molar mass. Is it visible? Volume at STP by, so volume at STP by 22.4 liter, volume at STP by 22.4 liter equal to mass by molar mass. This is the formula. Okay. So volume at STP by 22.4 liter. So what is the volume they have given? 11.2 liter. So 11.2 liter by 22.4 liter equal to, so what is the mass? 14 gram. Yeah, what is the mass? 14 gram. So 11.2 liter of a gas, 11.2 liter of a gas at STP weighs 14 gram. So which of the following is the exact gas? Okay. We don't know molar mass. Yeah. So you just do a cross multiplication, then you will get a correct answer. So molar mass equal to, So actually here 11.2, it is going to cancel 2 times, then 1 by 2. You will get 1 here, here get 2 here. So 14 into 2, 28. 28 gram per mole. Yeah. So 11.2 liter of a gas, 11.2 liter of a gas at STP weighs 14 gram. Which of the following is the gas? Okay. So what is the molar mass? 28 gram per liter. So 28 gram per liter means what is the suitable here? Let's look at carbon monoxide. So carbon 12 gram, oxygen 16 gram. So 12 plus 16 how much? 28 gram. Then 28 gram means this is the correct answer. Fourth option is the correct answer. Is it clear? Just have a look. So what is the question? 11.2 liter of a gas at STP weighs 14 gram. Which of the following is the gas? Yeah, which gas having this much? Volume at STP by 22.4 liter equal to mass by molar mass. This is the formula. You just use this formula, then you will get the correct answer. That's it. Very simple question. Yeah, take screenshot. Okay, next question. In general, high performance liquid chromatography, HPLC. In general, high performance liquid chromatography cannot be used to identify. Yeah, cannot be used to. Yeah. In general, high performance liquid chromatography. Actually, high performance liquid chromatography used for to identify various pigments in a leaf extract. Yeah, actually can be used to identify various pigments in leaf extract. Next, separate organic pesticides. Yes, by using HPLC, we can separate organic pesticides. But here, what is the question? Cannot be used. So by using HPLC, we can't determine arsenic content in a water sample. Yeah, this is cannot. Next, O2 content. Yeah, this is also cannot. We can't able to find. Actually, it is a completely theory question. There is no logic and magic. You just go through HPLC, you will get full clarity. That's it. You just go through chromatography concept, you will get this concept. You will get this answer very smooth manner. Okay, here what is the question? HPLC cannot be used to determine arsenic content in a water sample and O2 content in a given gas sample. Then CD means fourth option is the correct answer. Yeah, just have a look. This is also very simple question. Next, let's move to next question. Yeah, 1 mole of carbon dioxide 1 mole of carbon dioxide and 1 mole of ammonia are placed in a container kept at 850 degrees Celsius. What is the ratio of effusion rate of NH3 to CO2? So effusion rate, we need to find out effusion. So effusion concept. So here what they have given ratio? What ratio they have given? Ammonia and CO2. Ammonia and CO2. Yeah. So rate of NH3 upon rate of CO2. So this is the formula, square root of CO2 by NH3. Yeah, what is the CO2 value here? 1 mole of carbon dioxide and 1 mole of ammonia. 1 mole of carbon dioxide and 1 mole of ammonia. CO2. Carbon dioxide means CO2 and ammonia means NH3. You just find out the molecular mass. So CO2, what is the carbon value? 12 gram. O2 is nothing but 32. Totally you will get 44 gram, isn't it? Yes. Next nitrogen means 14 gram and hydrogens means 3 hydrogens means 3. Totally you will get 17 grams. So what is the answer? Square root of 44 by 17. So what is the correct answer here? First option is the correct answer. I think my explanation is very clear. Let's move on to next question. Yeah, this is also simple question. You just go through states of matter concept, you will get this type of questions. Clear? Yeah. Next. Bleaching powder is prepared by the action of Cl2. Yeah. How to prepare bleaching powder? So what is the formula of bleaching powder? Everybody knows bleaching powder formula, CaOCl2. First formula, bleaching powder formula. Bleaching powder formula, CaOCl2. CaOCl2. This is the formula. So what is the question? Bleaching powder is prepared by the action of Cl2 on. Action of Cl2 on. Slacked lime. First, what is the formula of slacked lime? Slacked lime formula, CaOH taken 2 times. Just a second. CaOH taken 2 times. This is the formula. Quicklime. This is the formula. Next to limestone. This is the formula. CaCO3. Next to soda lime. This is the formula. NaOH plus CaO. Sometimes they are going to ask like this also. What is the formula for slacked lime? Slacked lime, lime water, both are same. Don't get confused. CaOH taken 2 times. Next to quicklime, CaO. Next to limestone, CaCO3. Sometimes limestone formula, marble formula, both are same. Don't get confused. Clear? Next, soda lime, NaOH plus CaO. This combination is called soda lime. By using soda lime, we can eliminate CO2. Yeah. So what is the bleaching powder formula? CaOCl2. So bleaching powder is prepared by the action of Cl2 on slacked lime. Yeah. First option is the correct answer. Let me explain clearly why first option is correct. I will explain clearly. So CaOH taken 2 times. So whenever treated with Cl2, what you are going to get? You are going to get CaOCl2 and water molecule will be eliminated. Water molecule will be eliminated. So let me explain very clearly. So this is the formula. You can write like this. CaOH. Actually mechanism no need. But sake of yourself, I am going to give mechanism also. So CaOH taken 2 times, this is the formula. So when you treat it with Cl2 means you can take like this. Yeah. So one side it will get positive charge and another side it will get negative charge. Okay. So CaOH, actually Cl minus, what happened? Cl minus is the living nucleophile. It can able to attack. So that means what I want to say is, here OH minus will be eliminated and Cl minus will be attacked. So here OH minus will be eliminated and Cl minus will be attacked. Cl minus will be attacked. Then finally you will get answer like this. CaClOH plus OH minus. That's it. Yeah. Next, what will happen? Next, we need to react with Cl plus. Actually oxygen having lone pair, then oxygen going to attract Cl plus, then finally it forms like this CaCl OH Cl, then oxygen get positive charge. Next what will happen, this OH minus going to abstract H plus, then water molecule will be eliminated, then you will get CaOClCl like this ClOCl. This is called CaOCl2. Yeah, actually this is the exact representation of bleaching powder. This is the exact representation of bleaching powder. ClCaOCl. Clear na? Shortcut representation CaOCl2. Okay, anyhow, bleaching powder is prepared by the action of Cl2 on slackered lime. So first option is the 100% correct answer. I think my explanation is very clear. If you want to take, you can take screenshot also. Let's go to next question. Yeah. On adding dilute acid to X, produced a compound Y. So which has rotten egg smell, compound X and Y respectively. Okay. So here what is the question? On adding dilute acid to X, produced a compound Y which has rotten egg smell, compound X and Y respectively. Compound X and Y respectively. Yeah. So let me explain very clearly. This is also very simple question. This is not a big question. Just have a look. Let's take this one. FeS. Whenever FeS is treated with dilute acid, I am going to take HCl. Dilute HCl. Then what will happen? It forms like this FeCl2 plus H2S. Yeah, H2S having rotten egg smell. Rotten egg smell. Yeah. So finally what I want to say is FeS is nothing but X. X treated with dilute acid to give rotten egg smell. This is Y. So what are X and Y? So what is the correct answer? Option 2 is the correct answer. Yeah. Just have a look. Just have a look. Next, 57. If 20 gram of CaCO3 is treated with 20 gram of HCl, how many grams of CO2 is produced? Mole concept. This is a mole concept question. Listen very properly. 20 gram of CaCO3 is treated with 20 gram HCl. How many grams of CO2 is produced? First, if you want to find an answer, first you need to write equation, exact equation. Just have a look. CaCO3 treated with HCl, it forms like this CaCl2 plus H2O plus CO2. Yeah. CaCO3 plus 2HCl gives rise to CaCl2 plus H2O plus CO2. Okay. So here actually first we need to find CaCO3 molecular mass and HCl molecular mass also. CaCO3 molecular mass 100 gram. 100 gram. HCl hydrogen 1, chlorine 35.5, total 36.5. So 2 into 36.5 you will get 73 gram. 73 gram. CO2 44 gram. Here CaCl to H2O we don't require. Why? Because here what is the question? How many grams of CO2 is produced? That's it. CO2 is our requirement. So no need to focus on CaCl2 and H2O. Leave it, no problem. Okay. So 100 gram CaCO3, total 100 gram. So 100 gram CaCO3 whenever react with HCl it gives 44 gram CO2. But here what is the question? If 20 gram CaCO3 when react, how many grams of CO2 will be produced? Actually here what is the deciding factor? This is the deciding factor. This one and this one. These two are the deciding factors. Yeah, listen very properly. CaCO3 and there is CO2. Okay. Let me explain very clearly. 100 gram CaCO3, 100 gram CaCO3 gives 44 gram CO2. Next, 20 gram CaCO3 gives 20 gram CaCO3 gives how much? 44 by 100 into 20 gram. That's it. How much you are going to get? 21s, 25s. So 5, 8, 8.8 something you will get. So what is the answer here? Option 4. This is the correct answer. This is the 100% correct answer. Yeah. So 100 gram CaCO3 gives 44 gram CO2. But 20 gram CaCO3 gives how much? 8.8 gram. So you need to find like this. Clear na? Yeah. I hope my explanation is very clear. Let's move on to next question. Next, approximately how much time it would take to react Avogadro's number of atoms at a rate of 1 billion atoms in 1 second. 1 billion atoms in 1 second. Actually, this is the direct question. Yeah, 1 billion 19 into 10 power 6 here. Clear na? It is a faktu direct question. No need to focus on it. Next, input materials for the Solvay process. Yeah, Solvay process, it is very, very important. By using Solvay process, we can prepare sodium carbonate. By using Solvay process, we can prepare sodium carbonate, Na2CO3. Yeah, let me explain very clearly. So here, what is the question? Input materials, raw materials. What are the raw materials to prepare Na2CO3 by using Solvay process? Sometimes in examination they are going to ask like this. By using Solvay process, which compound we are going to prepare? Na2CO3, sodium carbonate. But actually here one logic is there. By using this process, we can prepare sodium bicarbonate also. Yeah. So let me explain very clearly. So I am going to explain Solvay process. Solvay process. Scientist name Solvay. First step. Whenever NH3 treated with H2 with carbon dioxide, you will get ammonium bicarbonate. This is the first step. Second step, ammonium bicarbonate treated with NaCl, you will get NaHCO3, NaHCO3 plus NH4Cl. Next, NaHCO3, actually NaHCO3 is nothing but sodium bicarbonate. When 2 moles of NaHCO3 on heating, it forms like this. Na2CO3 plus H2O plus CO2. Clear na? Yeah. So actually NH4Cl, this is the extra step. If you want to break down NH4Cl, when you treat it with lime water, you will get answer like this. CaCl2. Actually here you better to take 2 moles. Yeah. CaCl2 plus 2NH3 plus H2. That's it. That's enough. That's more enough. 2 into 4, 8 hydrogen. Here 2 hydrogen. Total 10 hydrogens. So here also you need to take 2 moles. Here also you need to take 2 moles. That's it. Clear na? Okay. So anyhow, what are the input materials? Just have a look. What are the input materials here? These are the input materials. NH3. Water, that is common thing. Leave it. CO2 and NaCl. So NaCl, CO2, NH3. These are the input materials. Just have a look. Yeah. NaCl, NH3, CO2. So what is the correct answer here? Yeah, fourth one is the 100% correct answer. This is very, very important. Very much important. Clear na? And one more important point, let me explain clearly. By using Solvay process, we can prepare Na2CO3. We can't able to prepare K2CO3. If you want clarity, you just go through my videos. That's it. Anyhow, here what is the correct answer? Fourth one is the 100% correct answer. Next, identify conjugate acid base pairs from the following. Identify conjugate acid base pairs from the following. Okay. So, what is conjugate acid and conjugate base? What is the relation between these two? Yeah, very simple definition. If there is a difference in one hydrogen, one H plus, yeah, one H plus difference between two species, that is conjugate acid base pair. That's it. Difference between two species, one hydrogen difference, only one hydrogen, H plus difference, that's it. H plus difference between two species, that's it. Let me explain very clearly. So here 1, 2, 3, 4, 5, 6, total 6 they have given. How many conjugate acid base pairs? Let me explain clearly. First one HCl NaOH. No, there is no relation. Yeah, B. What is B? H2O and OH minus. Yeah. What is the difference between these two? Only one H plus is the difference. Yeah. So when you remove H plus here, you will get OH minus. When you add H plus, you will get H2O. So what is the difference? H plus. That's the reason B is the conjugate acid base pair. Next, what about C? H2SO4, SO4 2 minus. So actually here 2 H plus difference. But what is the condition? Only 1 H plus is the difference. That's the reason option C. This is not a conjugate acid base pair. Next, option D. HClO4 and ClO3 minus. HClO4 and ClO3 minus. Actually hydrogen difference is there, but here 4, here 3. So there is no relation. This one also not a conjugate acid base pair. Next, what about E? CH3NH2, CH3NH3 plus, CH3NH2 and CH3NH3 plus. So what is the difference here? 1 H plus is the difference. So when you add H plus, you will get like this, CH3NH3 plus. So when you remove H plus, you will get like this, CH3NH2, that's it. So what is the relation between these two? Conjugate acid base pair. So the E also conjugate acid base pair. Next, what about F? H2SO3 HSO3 minus. Yeah, this is also conjugate acid base pair. Why? Because when you remove H plus, you will get like this, HSO3 minus. When you add H plus, you will get H2SO3. So this is also conjugate acid base pair. Don't get confused. What is the logic here? H plus is the difference. H plus, it is called proton. Proton difference between two species, that is conjugate acid base pair. That's it. I think my explanation is very clear. Then what is the answer here? BEF. Yeah. Option 3. Third option is the 100% is correct answer. Just have a look. If you want to take, you can take a screenshot also.
తెలంగాణ పోటీ పరీక్షల్లో ప్రభంజనం సృష్టిస్తూ స్టేట్ నెంబర్ 1 గా రాణిస్తున్న S&S పబ్లికేషన్స్.
తెలంగాణ గురుకుల 100% ఆన్లైన్ క్లాసులను స్టేట్ నెంబర్ 1 ఫ్యాకల్టీచే అందిస్తున్న కోర్సులు.
గురుకుల తెలుగు కంటెంట్ అండ్ మెథడ్స్,
గురుకుల మ్యాథమెటిక్స్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల ఇంగ్లీష్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల సోషల్ స్టడీస్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల ఫిజికల్ సైన్స్ కంటెంట్ అండ్ మెథడ్స్,
గురుకుల బయోలాజికల్ సైన్స్ కంటెంట్ అండ్ మెథడ్స్.
పేపర్ 1 జనరల్ స్టడీస్, పేపర్ 2 పెడగాజీ, పేపర్ 3 కంటెంట్ తో 100% సిలబస్ ను పూర్తి చేసి ఆన్లైన్ క్లాసులను అందిస్తున్న ఏకైక సంస్థ.
మీ ఉద్యోగ సాధనలో మీకు తోడుగా మీ S&S పబ్లికేషన్స్.
ఆన్లైన్ క్లాసుల కొరకు S పబ్లికేషన్ యాప్ ని డౌన్లోడ్ చేసుకోండి.
మరిన్ని వివరాలకు సంప్రదించండి 80705577 and 9032064822.